Good morning. So we are starting a new unit today. We're going to be focusing on functions. You got to be very familiar with a lot of the language going on in this one so that you understand what they're asking. So today we're going to be focusing strictly on domain and range, and we're going to see what that looks like in both graph form and actual function form, like the equations. So the domain, whenever they're asking about the domain, they're referring strictly to the x values, which is always considered the input. You got to become familiar with this. The range is always the y values. Now remember, we're always looking at something like this. We're going to be writing our functions as f of x equals 2x plus 5. Let's just say we're doing this one at first. I'll do this one in a minute. So we'll come back to this in a second. So this is your y values or your output. Think of it as like the answers you get. Whereas this right here is your x values or your input. Okay? Remember, the answers you get, that's what it essentially means. Now, if I'm looking at these graphs, I'm asking you guys, what is the domain and range of these three graphs? Well, you would say your domain, just call it your D, is all real numbers because it exists going all the way to the left and all the way to the right. So that's why it's always going to have all real numbers. And your range is also all real numbers. And the way you know this is because it's going down forever and up forever, so it's include all your y values as well. This one's a little different. Now, on this one, even though it looks like it's going vertical here, you actually know that it exists in both directions no matter what. So you would say your domain is all real numbers for this one, but your range is now considered, let's just say it goes here at y equals 2. Let's say this is 2. Your range is y is greater than or equal to 2. That's where it exists above. Range is with an E. So there's that. That's how you do this one, okay? Now this one's a little more, it's just about like look at the graphs and say what constricts you on your x and your y values. So now on this one you can recognize that, again, this is a bad drawing, but just play along for a second. My domain is, it goes from your x is greater than or equal to, let's say this is -1, but less than equal to, let's just say this is 4 right here, okay? So there's your domain. That's how you'd express it because it exists. This function only exists between -1 and +4 as far right. And your range is going to exist between as low as -1 greater than or equal to 1. You represent it as y. And it goes up as high as 1, 2, 3, 4, 5. Less than or equal to 5. That is how you express domain and range with functions like this. Now going on, let's say I use this function right here, okay? Let's say I ask you guys a question where I want to know what f of 3 is, okay? If I don't know what f of 3 is, this is saying, this right here is the input, okay? So the way you would go about solving this is you would do f of x equals 2 times 3 plus 5. So f of x equals 6 plus 5. So your output, f of x equals 11, okay? That's how you do that. So this again, the vocabulary and the wordage of everything and just the process of this might confuse you a little bit, but this is telling you when you see the number in the parentheses, this is saying put this in the input and then solve for it. Okay. Now let's say I got something different like this. Okay, just for the sake of structure, I'll leave this up so you see the difference. It's using the same function. Let's say I said this is saying find the input when the output is 22. Okay, I'm just hypothetically doing this one. So now this is telling you when they say, they provide you with this and no explanation, this is saying find the input when the output is 22. So you go ahead and solve it. So you do 22 equals 2x plus 5 minus 5 from both sides. 17 equals 2x divided by 2. X equals, you can use a decimal in this case because it's exact, at 8.5. That's how you do something like that. Let me just scroll this down so you can see all this, okay? Let's do some other ones. Get a good grip on this for today.
Mr. Chua and Mr. Chua, please report to the balcony door to assist Mr. Min. Mr. Chua and Mr. Chua, please report to the balcony door to assist Mr. Min. Thank you.
So now I want to know what is the domain of this function? Domain of this function. Well, I know that I can never have any negative numbers under the radical sign. So your domain is going to be x is always greater than or equal to 0. because you can have 0 in there in this case, all right? So this is okay, all right? And your range is also going to produce only positive numbers. So your range is y is greater than or equal to 0. It's essentially you guys using equalities for this because that's showing you to understand the full concept. Now on this one, let's say I have another one such as, f of x equals, see this? F of x equals, let's say it was 2 over x plus 3, okay? Well, when we're dealing with fractions, you guys got to remember that you can never have 0 in the denominator, but you can have negative numbers. So in this case, the only thing x cannot equal, your domain is going to be listed like this. X cannot equal negative 3. It cannot equal negative 3 because negative 3 plus 3 produces 0. But I mean, this is telling the person that's interpreting this function that x can be any number, negative or positive, just not negative 3. And your range is going to be all real numbers. Because in this case of this fraction, you're not constricted to anything. It can be any negative number, any positive number. Guess what? This can also equal 0 if it needs to, because it's allowed to equal 0. But just the rule of fractions, you cannot equal 0 on the denominator. So that's pretty much the bread and butter we're doing today. But you will see this in today's work. I'll see you guys in class.